Problem 5. Equation of a line H is wonderful. 2x plus y equals 1. Um, they're telling me line M, some other line, is the image. Right, once you hear image, you know a transformation happened. Okay? And they're telling you it comes from our original line H after a dilation. Right? So that dilation was making shapes bigger, or in other words, in this case, a line further away from some point. They're telling me the scale factor is 4. And what we need to know in this kind of a problem, when you have dilation of a line, you really need to focus in on the point of dilation. Because it's going to be one of two things. It's either going to be the origin, which it is here, or it's going to be some point. Okay, typically on the line. In fact, only on the line in the regions, but let's not get ahead of ourselves. This is not that second case. So when it's about the origin, here's what you need to know. You need to find the original slope and keep it, because lines are parallel, right? Dilated lines are parallel. So if things are parallel, they're going to have the same slope, right? Parallel is the same slope. And then the other thing we need is the original y-intercept, or in other words, the b value, because this is going to get multiplied by the scale factor. And that will be what we use to make our new equation, because that's what they're asking us. They're saying, what is the equation of line M? And an equation follows y equals mx plus b. And m is the slope, and b is the y-intercept. So that's what we'll need to write the new equation. And we're going to keep the slope from our old equation because they're parallel, and we're going to multiply our y-intercept by the scale factor to find the new one. So let's gather that information, and then we'll substitute. All right, so we've got the original line here, and that is 2x plus y equals 1, and we need to solve for y, because we need to put it in that y equals mx plus b form so we can find the slope and the y-intercept very easily. So I'm solving for y. That's what I want. So I need to get rid of this 2x. I'll do the inverse operation. Whatever I do to one side, I do to the other. And I can see y equals, I'm going to keep this 2x in front because I can see, your x term should come out in front. You don't have to, but it will just be easier to read. And I'm going to stick this plus 1 in the back. Okay? And when I go to look at this, I know the number in front of x, the coefficient on x, that is my slope. My slope is negative 2, and we always write it as a fraction. So I can put that over 1. And then this number at the back, that plus 1, that is my y-intercept. And this is for the original. The new line, the dilated line, scale factor 4, it's going to have a parallel slope. So its slope is going to stay the same. But the y-intercept is going to get multiplied by 4. So we're going to have our old y-intercept of 1, and that's going to get multiplied by our scale factor, right, 4, and our new y-intercept is going to be 4. So we're going to have a slope of negative 2 and a y-intercept of 4. So when we go to substitute this information in, our new equation will be y equals this slope, that negative 2. I'll just rewrite it. minus 2, and that goes in front of x, and then our y-intercept is this 4, so plus 4, and that will be the equation of the dilated line. I guess I'll take the time to just kind of show you in another program. If you buy that explanation, great, you can move on. But what we can do is we can open up a program like GeoGebra. We can turn on the graph, and we can actually plot this thing. We can plot 2x plus y equals 1. I can do 2x plus y equals 1. Yep, 2x plus y equals 1. Awesome. Boom. And they told us we're going to dilate about the origin. The origin is 0, 0, right? Point about the origin. And we are going to dilate this object about the origin, scale factor 4. Yeah, there we go. Good. And I'll color that green just so you can see the difference. Red. Here was our original line. Y equals negative 2x plus 1, which is what we solved for down here. Okay. And you can see that has a y-intercept of 1 and a slope of down 2 and to the right 1, that negative 2. Our dilated line is represented by the equation y equals negative 2x plus 4, which is what we said the answer is. And that's basically saying, look, when you dilate that line, these lines will be parallel. The only thing that's going to change is the distance your y-intercept is from the point of dilation. Here we have like a distance of 1, and that's going to increase from not 1, but to 4 times 1. So 1, 2, 3, 4. That distance is what's getting dilated. So that's what's changing in this problem.